welcome back. Now, if you remember in the very first video, I said reactions that are exothermic, that is delta H is negative, are usually spontaneous, and if delta H is positive, the reaction is endothermic and generally is non-spontaneous. While that statement is quite true, it's not 100% conclusive, okay? So there's two other pieces of information that we need to add, and then we get some other information out of it, which is much more conclusive, right? So the two other terms we need is entropy, which we have not included in the calculations prior. We've just focused exclusively on enthalpy, and then the temperature, which is also not included in the calculations. So once we put all that information together, we get a numeric value for delta G, which is Gibbs free energy, right? And if that delta G is negative, then the reaction is spontaneous. And if delta G is positive, then the reaction is non-spontaneous. Okay? Now, let's give you an equation. You do not have to memorize this equation, but you do have to remember this information. So if Gibbs free energy is negative, the reaction is spontaneous. Delta G is positive, then it's non-spontaneous. Now this is a much more conclusive piece of information, and delta G0 equals delta H0 minus, I always prefer to put this term inside the bracket because, you know, things can go wrong, and they go wrong pretty badly. Now, this equation is balanced, and I think I will probably give you a balanced equation for this particular problem. This is the easiest of them all. It's mere plug and chug. But there is a vendetta, which is enthalpy is typically expressed in kilojoules per mole. So that's given to you. It's negative 136.9 kilojoules per mole. Minus T must be in Kelvin, which is also no problem, but the problem is the delta S0. You see that value is in joules, and people that write exams know exactly that with all this information on the screen, it's easy to overlook that one unit. And they're going to give you an answer choice that you might get out without fixing it, and you think, oh, you got the right answer. Well, you're going to get the wrong answer. So you have to convert joules to kilojoules. That is, you divide whatever that value is by 1,000. So 120.7 over 1,000 would be negative 0.1207 kilojoules per mole Kelvin. You have to make this adjustment. Otherwise, your answer will be messed up. So put that value here. So negative 0.1207. You remember from your math classes, when you multiply to negative, it'll be positive. So it's 136.9 plus 298 times 0.1207. Let's get the math underway. It's plug and chug, but if you don't do that 1,000 conversion, you're going to have a problem at hand. So 298 times 0.1207 minus 136.9, which is negative 100.93 kilojoules. The answer is negative. You see that sign is negative, so it's spontaneous. And that is it. I'll see you back with another problem, so stay tuned.